Yes, I use a microphone. It's not magic. There's a microphone here. Well,
right.
hello.
What is happening? It's Monday. Let's recap real quick. It's Monday. The weather in Texas is winter now. So this is day one of winter. And I think we're going to have maybe 3 whole days of winter at some point the rest of this year. I'm kind of excited.
That's fantastic. In Southern California, we have summer and then kind of cold, like 60 degrees, and that's freezing. That's winter. And then we're back to summer again. So
nice.
Well, here in Seattle, just without warning, we went from nice fall weather to freezing cold winter. Yesterday morning, I went out for a run with the dog, and it was 32 degrees.
Oh my gosh, I can't even. So I used to live in Seattle, and I eventually had to leave because of the winter. And then at one point, I lived in New York for several years, and definitely had to leave because of the winter. Like I can put up with it for many years, but there's just a point at which I'm like, I got to get back to some place where there's some heat. So yeah,
I hear you. And so let's say hello to everyone in the audience today. So
yeah.
Alex Masha, of course. Hello.
Welcome back, Alex Smasha, formerly AKA the Smasha.
Yes, we have a lot of formerly and now new named viewers.
Who else we got? We got
we have FA. Hey, FA. So in case you may not have noticed, based off the title of the show, we are going to be talking Copilot this week, but we have a really fun theme, and it's Spooktacular, right? So it's a Halloween themed week, and we're going to be doing some really cool stuff. But before, I won't get into it just yet. I think we should continue to say hello to everyone. What do you think?
Who is FA? You seem to know him.
FA is and so, by the way, we didn't even introduce.
I figured we were going to get to that, but here, yeah, let's talk about Austin. We have Austin.
Austin, introduce yourself.
Hey, I'm Austin. I'm a developer on the Copilot team. Been working on it for quite a while now, and I'm really excited about some of the features that we're going to talk about and stuff that's going to be used this week.
Nice.
So just, Austin is being modest, as, the Copilot team always is. They've built this amazing tool, and Austin has what we're going to talk about today with what we're going to build is with scheduled jobs. And again, Austin is the brains behind the simplicity of the scheduled job functionality in Copilot. So it's going to be really fun to walk through that and talk about it.
I like how you said that, and extra emphasis on simplicity, because this definitely has taken something that historically is really hard for people to figure out. How do I mean, obviously it's easy to schedule a cron job on a system, but like, what if that system's down? What if you have a single point of failure? What if it's busy when it comes time to run the next job? There's lots of what ifs that when you get into distributed computing, you have to figure out how to solve for. And Austin basically just solved all your problems for you. So welcome.
Welcome. And I just wanted to go back to, Mini Jerome, hello, welcome back. And he's saying winter does not exist in Texas, said from someone living in Canada. So
nice. Yeah, absolutely. Who else do we have? We have some new people. I don't recognize Lost Algorithm. Oh, you do? Okay. Well, welcome back. If you are returning, good to see you.
Like a hand raise? Is that what that is?
Maybe, or a wave, maybe. I bet it's a wave.
That makes more sense.
Sringara, welcome. Good to have you on the show.
That's
Jeffrey Milan,
one of our teammates.
Oh, nice. Awesome. So also from the Copilot team. And then Jeffrey Milan. Hey there. Yeah. Welcome. Is he also on the Copilot team?
No.
Oh, okay. And then, of course, FA, we know, is also on the Copilot team. And I have to say, like, I get the privilege of being in Slack with this team, and it's awesome. Like every morning, I get my cup of coffee. Here it is, by the way, this morning's cup of coffee.
Cheers.
Little cowboy going on. So I go and I get my cup of coffee and I sit and I sip and then I open up Slack. And at the top of my list is Copilot. And I always see, something along the lines of "Good morning, Copiloters," and it just makes me happy. It's such a happy Slack to be in, and it's awesome. There's like a recap of what happened. You can see, commits going through and stuff like that. It's just everything is so cool. In that, and so happy and positive in that Slack. So this is a great team. And on that note, Copilot let's talk about what is Copilot real quick, and the fact that it's open source and everyone can participate. What is Copilot?
Who wants to take that one?
I can take it.
Take it.
So, in short, Copilot aims to be the easiest possible way to get containers up and running on AWS. So, one or two commands to initialize and deploy an application wrapped in a Docker file. Start to finish, the whole process should take about 5 to 10 minutes to get your front end or load balanced web service up and running in its own private cloud behind a load balancer, receiving traffic if you have a domain name with SSL enabled.
And the SSL edition was like a relatively new edition as well, right?
That's been around for actually a little while. We didn't do a great job of documenting it, but the domain name flag has been in Copilot for some months now.
I like how some months is a little while in Copilot terms. So Copilot is an awesome project, open source. Anyone can contribute to it, and people have already started contributing to it. We have a community starting to build up around it. There have been PRs merged from outside sources. So even in fact, wasn't there one over the weekend contributed by an external?
Yeah. So last week we had a couple of PRs come in from a contributor who, among other things, helped us add the cache from and target fields to the Docker execution. So now, once that gets merged in, Copilot is going to be able to support multi-stage builds using the build section of the manifest.
That's so cool. So if you're out there and you're wondering, wondering about the tool and you find some, you have ideas about how it should work, or you want to contribute, absolutely, open issues, open PRs, it's a great team to work with. So definitely jump in, look at how you might be able to contribute, because this is an awesome team to get to know. So David's kind of like leading us along a little bit. David, welcome, by the way. I'm so excited for the spookiness. So what are we going to do today? What are we going to build? The title of the show is Spooktacular Week. What does that even mean?
So I think I'm trying to think of where this all started, but of course, it's I think the Copilot team was like, hey, we have a really good idea. And then they brought it up, and Brent and I were like, yeah, absolutely, we're doing this. So the idea was, it's Halloween. Copilot just had a new feature release. Let's showcase Copilot this week, but let's do something that's just not deploying Nginx, like we always, tease, like we do. But let's actually deploy, or let's build something that's Halloween themed. So we are going to build an application that's going to have a nice front end that's going to tell us, and if I butcher it, FA, Austin, please, correct me. But basically, we're going to have a front end that's going to show us all the emojis that are tweeted with the AWS Copilot hashtag. So over the coming day or two, we're going to look for tweets that that have AWS Copilot hashtag, and we're going to basically have a tally of what Halloween themed emojis are used the most.
Oh, so that's cool.
And so to do this, this is really going to be, this is like what I like to say, this is really a real world scenario. So we had the idea, we had a meeting, we talked about it, and we split up the work. So my portion that I got to work on, which by the way, being like back in like just kind of feeling like I'm a part of a development team again, it was so nice. It just gave me all the good feels inside. But so I wrote the back end job. So this is a scheduled job that's actually going to just scrape Twitter. So what we're doing is we're starting from the back, and then we're going to work our way to the front end. And the first piece of this for everything to work here is we need to get this data from Twitter. So that's where we're going to start today. So today we're going to build the scheduled job, and Austin's going to give us, as I build it, he's going to narrate all the amazing stuff that he built to make this as easy as it is. And then tomorrow we're going to deploy some backend services. So once we gather this data from Twitter in the scheduled job, we need to ship it somewhere or put it somewhere. So we're going to build an API service that's going to ingest that data, that's going to parse through that data. And then we're going to have essentially that'll write to a database. So we'll look at how do we initialize a database with Copilot, and then we'll deploy the front end, most likely Wednesday, to bring it all together. Does that sound about right, Austin?
Yeah, that was a great description. Okay. Yeah, basically grabbing data all the way through storing data, parsing data, handling requests between services using service discovery, and hitting a load balancer target to see the front end at the very end.
That's awesome. And I mean, that's basically a startup, like
exactly.
That covers so much. There is a question from Lost Algorithm. Only having seen the README, is Copilot aimed at microservice folks, or does that also suit generic deployments in general? And I don't know. I'd say microservices, but really you could broaden that to say just anything running in a container, right?
Yeah, that's correct. You can, with the manifest files that Copilot generates, we make it easy to increase the resource limits or capacity of your container. So if you have a really resource-intensive application, you can give it higher memory or compute overheads. And auto-scaling is dead simple with specifying a min and a max count. And we do some really intelligent sort of automated auto-scaling alerts that we set up by default whenever you enable it. So really, if your service needs replicas, we make that easy. If your service needs higher compute and memory overheads, we make that easy too.
Nice.
But it all does have to run in a container.
Yeah. And I think that's fair. And in fact, that's probably what most people would prefer. Containers are easy, they're portable, they work the same wherever you run them. So, just having a CLI that can help get you going in the cloud, especially, when you couple it with Fargate, it's a win-win. Ian Rodriguez says he uses Copilot to deploy a WordPress app these days. So that's awesome. I'd actually like to talk to you, Ian. Let's figure out what your workflow is, because I would love to see WordPress updates going out using Copilot. That would be cool.
Yeah.
But why don't we get to it? We have a back end to deploy. So
a scheduled job.
Scheduled job to deploy. Fair.
Yes.
All right.
So let's get to it. And so what we'll do is I just want to start with the Docker file and just briefly review the code. I'm not going to go deep into it, but so you can see here, like I'm looking at this from someone who I know Docker and I know my code. Okay. And I'm not an expert in anything else outside of this. So I have my Docker file, which it's Python is my code. I'm installing the requirements TXT. This is just any modules that I'm using in my code. I need to make sure that I can have those installed. And then I'm just copying my code base, which lives under the scraper directory. And that's it. And the command when the container runs is scraper main py. So briefly, just to go through the code, I don't want to go too deep, but essentially all I do is I'm just talking to Twitter over the API. And I'm actually using a Python module called Python Twitter. And I'm just looking for any tweets that have a particular hashtag. So I do have some defaults here. If I don't set an environment variable, I'm just going to default to this. And so this is an example. We're looking for anything that is tagged with the hashtag AWS Copilot. And that's it. Okay, so I'm grabbing tweets and I'm just looking for that particular hashtag. And for the start, I'm just going to print those results. Tomorrow, what we'll do is we'll go from printing the results in the log output to actually shipping that to the API service. So we'll get into that tomorrow. So to start, all I need to do is I need an application. Okay, so this is something I kind of already, jumped the gun a little bit, but always in your Copilot, in your directory of your repo, if you run a Copilot init, this is going to set up my service. And if I don't have an application, it's going to help me set up my application as well. So in this case,
let's clarify, what's the difference in an application and a service?
That's a great point. So I'll answer, and then Austin, please feel free to fill in the blanks here. But essentially, an application is a collection of all of your services. So the application is kind of the umbrella. And your services are, for example, this scheduled job, a back-end API service, the front end. These are all services because all of these services are what encompass in my application, right? Which is giving you go ahead.
If you're thinking about, the way your team might be organized, you guys might be on the Spooktacular service team, or maybe we should call it the Spooktacular application team. And you all are building services. So collectively, you have an application, and that application is comprised of everything that you're building. So maybe that can map to organizations out there in our audience. If you guys are organized onto service teams, then you could just think of it as one service team, one application, and everyone gets their application that they deploy their services into.
Yeah,
exactly.
And not only is an application a collection of services, it's also different environments containing those same services. So if you think about this in the context of a deployment pipeline, an application can contain your test environment, which might be where you stage all of your code, make sure that it bakes and there's no errors when everything's running together. And you might also have a prod or a deploy environment where once everything you're satisfied is working in the test environment, you go ahead and promote that to production. And Copilot Pipelines makes this really, really easy. We allow you to set up an automated code pipeline, which sources from a Git repo and pushes code all from your source code, builds the image, pushes it to ECR, deploys it to the test environment, and then once you're ready, pushes to prod.
Nice.
Yeah, that was a good point. Is environments and pipelines. Those are, those definitely bring it to a whole. So I've already created an application. So for right now, I just created an application called Twitter Backend Test. So I have my application. It's up. It's running. It's available. So now the next step is I'm going to use the job parameter to the Copilot command. Austin, do you maybe want to walk through, what functionality is available with the Copilot job command, and what some of the different commands available are?
Yeah, sure. So jobs they're basically another way of running a containerized workload, right? So in order to manage them, we needed a separate command family to initialize, to deploy, to show what jobs exist in an application, and to generate the underlying cloud formation, right? So this first suite of job commands here, as you can see on Adam's screen, includes init, which writes the manifest, creates some infrastructure for the job, including like the ECR repo that the container will live in, the manifest, where you specify all of the different parameters of the Copilot job. Basically, that's like size, schedule, retries, timeout, all of that kind of stuff. There's deploy, which builds your container and pushes it to the cloud, to ECR, and starts a scheduled job using that container. Package just generates the CloudFormation template for a specific environment. If you need to ever migrate out of Copilot, or you just want to see what it looks like under the hood, you can run job package and will generate the whole 500-line CloudFormation template that describes the scheduled job, all of its roles and policies, the state machine wrapper that we use for resiliency, retry and timeout logic. And then, of course, there is job ls, which just lists everything there, and job delete, which will delete all of the data for that job from your application or environment.
And, so I actually have a job running at the moment. So I'm going to create a new one. So I'm going to do Copilot job init. And what do we want to name this job? So I'm going to name it Twitter Scraper Demo. And again, so what's really nice is this walkthrough, right? Where I don't have to know everything up front. I can just go through the walkthrough wizard, and it's going to get me to where I need to go. So it's going to ask me about my Docker file. I'm going to use the existing one. Now, Austin, I know this is your pride and joy right here. So this is where, if anyone here has ever, written a cron job, or, back in the day when, we used to have a cron server and we'd have to manage crons, it was always such a pain, right? Like I'd have to use some sort of config management tool to make sure my crons were always at the desired state. They're running as expected. There was just so much work that went into that.
Plus, you had to cron the config management tool, so it's like a circular dependency.
It is the ultimate cron pain. And also, Brent, with the exception of Brent, because he loves cron syntax, if you like, just trying to remember, I've Googled, there's this one website that actually, it's like cron calculator, and I always would go there to try to remember what cron syntax is. Well, I don't have to be that expert in cron anymore. Austin, why don't you talk us through the differences between when I'm scheduling my job, what the rate and fixed schedule is, and how that works?
Sure. So we have a lot of different ways for you to specify the schedule that your job runs on. So rate will just run it immediately after deployment and then on a fixed interval thereafter. So like a rate, you can just specify anything from 1 minute to an hour and 30 minutes to 24 hours. And we'll create all the infrastructure needed to just run that at that interval. Not corresponding to any fixed time, just say you don't particularly care about like when exactly the job runs, you just want it to run at a certain cadence or a certain frequency. Fixed schedule, though, that's how we let you specify an actual sort of cron expression. So we offer a lot of different predefined fixed schedules, from like daily or at midnight all the way up through yearly, which just runs once on January 1st and then again the next year. But like, we also let you type in a custom cron. So, everyone's in the chat's looking at crontab.gruber, right? So it's a 5 expression For a 5-element expression, or biggest or smallest to biggest, starting from the left. So that site here says 4:05. You specify the 5th minute of the 4th hour of the day, right? After that, I think it's day of month, then day of week. Things get really confusing once you start trying to specify both a day of month and a day of week at the same time.
It's an or.
In some crons, that's valid. Sometimes it's not. We do our best to translate from basic cron into AWS's Java flavored cron. So Copilot here uses typical Unix cron. You can find the syntax on Wikipedia for the wildcards we accept and the number of fields that we have.
Nice.
So for the sake of the demo, I want to go on I'm just going to do a rate. And
that's, what's funny is that's really what most people end up wanting. So rate's definitely going to be easier. So every 5 minutes or every 5th minute, the */5 cron syntax, this is going to be easier.
Yep. So let's have it run every minute. I'm feeling crazy. So, and this is it. I'm just typing 1M. That's my cron syntax.
All right. I want to see a pull request from Boat Joe now for the schedule for every full moon.
Yeah. Is there like a moon API that we can query?
There is. There has to be.
I bet there is. So I finished all my my inputs, which was job name, Docker file, and my schedule type, which I chose rate, and I wanted the rate to be every 1 minute. So now it is creating the ECR repositories and preparing for the actual deployment of the job. So I'm going to do a Copilot job deploy. And I already forgot what I named it. I think I named it Twitter Scraper Demo. As you can see, I already have an existing job because this is me. My mind is a little crazy. So now it's building my Docker file. So again, Docker build, your build sh, that doesn't need to exist anymore. It's all in Copilot. So it's building my Docker image. It's going to push that image to ECR, the Elastic Container Registry. And it's then going to create and deploy the scheduled job. And I'd like to actually dive into the scheduled job functionality, step functions, why you chose that. Maybe tell us a little bit about that, Austin. I'm actually going to go sneak ahead here and look at the step functions. Maybe you can walk us through.
Yeah, so there's a lot of different ways to get a job running on a schedule in AWS. There's a native ECS functionality to run a scheduled job. But what we decided to do was, instead of using that, we would wrap the entire thing in a step function state machine. That gives us some really, really cool extra features. So in addition to the schedule, which is kicked off with the CloudWatch event, the state machine lets us specify an overall timeout for the job, which I don't think ECS will let you do natively. And also it gives you resiliency. It lets you retry the run job state up to a set number of times with a given back off. So right now, this is just a really, really dead simple state machine, but we use this because, like I said, it gives us this extra resiliency and a little bit more control over how the task executes. So we default to, well, I'm not sure if we default to anything for retry and timeout. Those fields are pretty much optional, but we really, really like the state machine functionality. We just wrap every scheduled task in one of those so that we can really easily update the confirmation in case you want to add a retry or timeout later.
There's a question from Lost Algorithm that we may not know the answer to immediately, like off the top of our head, but I bet we could look it up. That seems to spawn quite a few resources over a few services. Is there some way to get cost estimates, or would you have to set that through limits on Fargate, et cetera? And so let's just talk through real quick while this is coming up. We pushed to ECR. So we have some storage costs to be concerned with there, but ECR does, we try to minimize that by compressing your container while it's at rest. So hopefully those are going to be relatively minimal. We are provisioning, of course, Fargate resources, and you can control the sizing of those resources. And I'm assuming, Adam, that your code is relatively efficient, and so you're using pretty small resources here. The step functions, is that just a scheduler? Is there even what is the cost to have a step function? I bet
Googling
it's like the step functions are charged based on the number of transitions that are required to execute. So I think a state transition is obviously going from one state to another in the state machine. So in our application here, we have, I think, a total of 2 state transitions going from start to run task to end. And
right.
The free tier here for state step functions is 4,000 transitions per month.
Yeah. So minutely, we're going to have two transitions to go from start to running to end?
Yeah, it looks like it.
Yeah. So how many minutes in a day? 86,400, or is that seconds?
That's seconds. It's 1,440 minutes.
1,440 minutes a day times 30 days.
Mm-hmm.
Times 30. And then what are the first, how many are free?
First 4,000 are free, and then it's 2.5 cents per 1,000 after that.
Yeah, so I mean,
it's pennies. It's pennies.
Negligible.
Yeah. So yeah, I mean, like there are costs here, but they are so small. And for what you're getting, I mean, think about, again, Adam, you were talking about, what you used to have to do to be able to get functionality similar to this. You used to have to run a dedicated server for it. And, that cost instead would be much, much higher. And then on top of that, you still had a single point of failure. So in reality, if you're doing it in production, you would have a set of servers, a cluster of servers potentially that you would be running these jobs on, and you would have to build coordination. Which one of them is going to be the leader? Which one of them might be the follower? And so on and so forth. So, yes, there's a cost. However, look at how small it is, and what the functionality is that you're getting. It's pretty incredible.
And it's so that has free tier. ECS itself doesn't have a cost. Fargate is the only thing really for however long it runs, right? You pay for that.
But that's what's cool about Fargate, and especially using this scheduled job on Fargate, is you're only going to pay for its running time. When it's coming up or when it's going down, you aren't paying for it. It's only when it's running, and you have those resources allocated. So, if we're doing this minutely, but the majority of scheduled jobs aren't really minutely. You would just keep something like that running. They would be like maybe hourly. And if it runs for a minute, you're paying for, a minute every hour. That's so easy.
And okay, so I want to really quickly talk about the manifest file.
Yes.
So I deployed my service, okay? And one thing I forgot to do was I forgot to update the manifest file when I initialized my my scheduled job. And in the manifest file, so obviously I have secrets in here, okay? I have secrets that I don't want to tell anyone. I don't want any of you to know. These are my personal secrets for Twitter. So Copilot has integration built in with Secrets Manager. So what I did before we started the show was I created SSM secret parameters, okay? And they're encrypted. KMS encrypted, and they're secure string parameters. So I needed these in order to talk to Twitter. So once I run the commands to create my parameters. All I have to do is in my manifest file, I just reference the name of that parameter in Secrets Manager. That's it. So there's a secrets top level key here. And then I just pass in my key value pairs as to this is the secret in Secrets Manager, Twitter access token. And then this is how I want to expose it to my container as an environment variable. Does that make sense?
Oh yeah.
So all I had to do was create my secrets and then reference the secrets in my manifest file. That's it. And that's all I needed to do. So now the next time I'm going to deploy my application, or I'm sorry, I'm going to deploy my my scheduled job, it's going to see those secrets and it's going to start working again. Because right now, which by the way, Copilot team, thank you. Earlier, I was telling you, I was having problems. It was a me issue, not a you issue. It's me, not you.
I'm used to that.
So you can see my application isn't logging and it's broken. And that's because the Twitter, the Python Twitter module that I use, it's basically just retrying silently behind the scenes. So we're going to update that secret, and which I did. And then we're going to push them out. And actually, I want to add an environment variable as well. So here's where I can declare my environment variables. And I want to say debug, and I'm just going to set it to true. So this is just so I get a couple extra print statements in the logs. So I'm going to do a Copilot job deploy. It's going to recognize that there are changes in my manifest file, and it's going to redeploy that scheduled job. And so Austin, I'm pretty sure I could do this, but can I wrap a scheduled job into a pipeline as well?
Yeah, so pipelines will deploy any scheduled job that's in your workspace. Pipelines deploy all jobs and services that are in the Git repo they're attached to. We made sure that was one of our big priorities, is making sure that it worked with our existing CI/CD functionality.
That's fantastic. And which, by the way, again, to wrap this into a pipeline, I'm doing it all through Copilot. And, I can do that tomorrow. Actually, we can even quickly run through that. But again, it's just using the Copilot CLI. I initialize a pipeline, and that's it. And then it will deploy the pipeline for me. Do you have questions?
Nice. Yeah, while that's deploying, we have a question. Why did we use Fargate for the Twitter bot? Can't we use Lambda to run Python script on a schedule? And yeah, you absolutely can. But Lambda, it's going to have a workflow that it requires. And this is just going to be part of a bigger picture. And, this is the workflow that we prefer to use. So the container is, there's lots of reasons to make choices. Now, also the question was, or EC2, and I would say that might be moving in the direction that we wouldn't want to move. I can maybe see us doing this with Lambda, but I don't think I would want to do it with EC2, because then I'm taking on even more responsibility of things to manage. So with Fargate, I manage everything inside the container. That's definitely all like on me, in scope, easy for me to do as a developer. But then and Lambda, exactly the same, manage everything inside your function. With EC2, I would have to end up managing, everything on the instance. And that's not really loving doing that these days.
The other super nice thing about using a Fargate container for this is that because we have all of our resources set up in an ECS cluster already, that container for the scheduled job will be able to hit the service discovery endpoints we set up for all of our front end and back end services. It has easy access to the load balancer, to resources that get deployed into the cluster. It simplifies a lot of the access and resource control by just deploying a Fargate container into this existing cluster.
Absolutely. And lost algorithm kind of touches on another characteristic. Just with a bunch of lift and shift stuff in front of me, I honestly like this. Seems like a good way to get a sense for the idiomatic choices that Copilot makes. And that's kind of what I was getting at a minute ago too. You know, containers are so portable. They can run the same anywhere. And you may have started off, you know, running this on, I don't know, your laptop or something, you know, using Docker for desktop. And so then just being able to get this out into the cloud in a serverless way using Fargate, I think that's really the win. You know, getting it out into Lambda is also a win for sure. And if that's what you want to do, then absolutely do it. But yeah, Fargate, I think, is just as winning.
Right. And at the end of the day, this is the beauty of AWS is you have the choice, right? There's plenty of choice here. And look, ECS, I don't manage a control plane. Fargate, I don't manage a data plane. So really, it's the same kind of operational overhead that you get with Lambda, which is nothing, right? I'm not managing EC2 instances. I'm not concerned about allocating space and all that. So,
awesome. And just sorry, following up one last message to close it out. Thought it was primarily used for Docker containerized apps, and it is. But Docker, if you just think of Docker as a packaging mechanism in this case, then you know really what you're doing is you're packaging up your code, you're shipping it out to an execution platform, Fargate, and it's running there in a managed way so that you don't have to manage that execution environment. All right.
And so you could just see this has been running as we've been talking. Every minute, these jobs have been running, and I can go back and look here, and I'm looking in the console. Let's scroll a little more. So you can see here, so you could, every time you update a task definition in ECS, a task definition is essentially the way to describe your container deployments. It gets versioned. So we're on version 2. So I can go to the last run of this particular, you see it's successfully stopped. And here's my output. So it's scraping Twitter, looking for anything with AWS Copilot hashtag. And you can see, there's Dave. Hello. He retweeted something I tweeted. So thank you. And you can see it. Look, here are the emojis. And so that's it. So we're now collecting data from Twitter. This was our first task in our grand scheme was we need to collect data from Twitter. And then next step is we need to figure out where to put all this data, right? And that's what we'll do. That's where tomorrow comes into play when we deploy our backend services. We're going to deploy our backend API, which is how this scheduled job is going to start shipping this data that it needs to process.
By the way, shout out to the CloudWatch Logs team for allowing at least some emojis to actually show up in the console. That's pretty cool.
Right?
Wouldn't have expected that.
That's awesome. So you could see, and again, another job is running. I was a little aggressive with doing it every minute, but I really did it to just show you. And again, same thing. So that's it, folks.
That's awesome.
The hardest part about all of this was just writing the code and my code, right? That's the challenge. Copilot made everything else, all the other aspects of deploying my code, crazy simple.
So let's just recap what, your workflow. You started off, you were writing some code on your laptop. You then thought, okay, this needs to actually run somewhere outside of my laptop. So let me stick it in a container. So you containerized it. Then you
ran that container locally, right? I wanted to test it local.
Mm-hmm. Then you just used Copilot and, Copilot init, and off you go. And now it's running in the cloud. And you didn't have to provision anything in the cloud ahead of time, except for, I suppose, maybe your secrets.
Yeah, that was the one thing.
Yeah, which makes sense.
Exactly. Automating secrets, that's not an easy problem to solve because it's always the chicken and egg thing.
all you're doing is you're putting them somewhere that your task is has permission to read them. So that makes perfect sense. But yeah, that's it. That's all you had to do. So now your code is running in a serverless way out there in the cloud, and it's resilient, it's orchestrated, it's you're only paying for what you're using, and what more could you ask for? That's incredible.
It's really awesome. And you can look, I can see Romain. He's our manager. I see his tweet here. I got his location. I got it all here, folks.
That's right.
But this is just the data from Twitter itself. But really the goal was to make it super verbose. So you can see here's the data we get from Twitter, which is a lot. And then here's the payload that I'm going to send to the API service tomorrow, which is a
nice
condensed version, of course. So
that's awesome.
Nice.
I'm looking forward to tomorrow. All right. So what's the plan for tomorrow then? Let's recap what we should expect for tomorrow.
Yeah. So Austin, tomorrow we're going to deploy a backend API service, right? Are we deploying another backend service tomorrow, or is it just the API? I'm trying to remember.
I think it's just the API. That'll host the database, and it'll do sort of the required transformations between tweets and emojis. It'll serve the front end all of the information that it needs to aggregate the emojis that have been collected and display it to users or to the World Wide Web.
Perfect.
Awesome. All right. So join us back here tomorrow, same time as usual, noon Pacific, 3 p.m. Eastern. And we'll be here and we'll continue the project. So until then, thanks everyone for joining us.
Thanks everyone. Thanks, Austin.
Thanks, guys.